again, using all those vertical asymptotes, horizontal asymptotes, slant asymptotes, very helpful for when we're going to come up and graph those rational functions without the aid of a calculator. With the aid of a calculator, it's not too bad. So, first thing we want to do is simplify f of x. And make sure we get rid of any common factors if there are any. Or just factor it out so you can readily see my domain and all that other. So, simplify is the degree of our numerator, n of x, is one more than the degree of the denominator, d of x. What do we want to do? We divide and find the quotient, which gives us the somebody said it. We just did it in the last example for me. All right, we go ahead. If the numerator is one more degree higher than the denominator, divide, whether it's synthetic or long division, to come up with a quotient, which gives us a slant. Okay. Once we've taken care of that, find and plot the y-intercept. How do we get the y-intercept? This is algebra, folks. Algebra 1. Put a u in the equation. Folks, how do you find a y-intercept? What? Joe or Michael, whoever said it. Michael? Yeah. When you find an intercept, folks, right, you just set the other variable equal to that 0. As Michael said, y-intercept by evaluating f of 0 or okay, that's the same thing as I'm going to say when x equals 0. You guys are overthinking stuff here. After you get the y-intercept, find and plot the x-intercept. How do we get the x-intercept? By finding the absolutely, by finding the zeros. How do you find the zeros? Set f of x equal to 0, which is the same thing as 1. You have a quotient. When is that quotient equal to 0? When is a fraction equal to 0?
Or when the top is 0.
So setting f of x equal to 0, same thing as just looking at when the numerator is equal to 0. It's been a long weekend, folks. So we have our x and y intercepts, plotted those. Then we can find our vertical asymptotes. Where do we get our vertical asymptotes from? As Joe said, so my denominator is equal to 0. If I've already defined my domain, how difficult is it to come up with the vertical asymptotes? It comes straight from the domain. It's a domain, we exclude all the numbers where the denominator is equal to 0. So if I'm looking for those values, we've already determined that from the domain. And then finding the horizontal asymptotes, what are we doing? Absolutely comparing the degrees. So now we have our asymptotes, we have our x and y intercepts. A lot of times that's not enough. You need some additional points. Find some points in between your x-intercepts and your vertical asymptotes, which give you definition fidelity. Is it going down? Is it going up? Which quadrant? Not which quadrant, but are we above the asymptotes to the right of them? So we want to find and plot at least one point between and beyond each x-intercept and vertical asymptote. My x-intercepts are at x equals. My vertical asymptotes are at x equal. So we're using these to split up our number line and just choosing a test point to find out, is it going down? Is it going up? Is it over here? Is it over there? And then we go ahead and use sharp, jagged curves, right? Okay. We use smooth curves to complete the graph. Between and beyond the vertical asymptotes. What that means is you have your vertical asymptotes, don't just draw it in between them. Don't forget there's something to the left of them, something to the right of them. Right? Make sure you cover the entire graph. So, everyone sketch the graph of f of x equals 1 over x plus 3. And it's still there. So, tough stuff first. Tommy, is it simplified? No common factors or anything like that, just 1 over x plus 3. So what is its domain? How do I find the domain? What numbers am I going to throw out? Exclude. Absolutely. The denominator cannot equal 0. As Tommy said, x cannot equal negative 3. So all real numbers, excluding negative 3, wind up being the domain. And what about my y-intercepts? What do we say? What did Michael say? You know that Michael knows it. How do you come up with that number? That's what that means. X equals 0, right? X equals 0 just gives us that. One over 3 is 1/3, folks.
The white name.
So, Alexander, what about the x-intercept? What are we supposed to do there? Let's do the same thing as setting numerator or denominator to 0. folks. Just did all this stuff right here, right? So, with our x-intercept, set the numerator equal to 0. So, when is 1 equal to 0?
Never.
Thank you. Which tells me what? There aren't any x-intercepts. And for our vertical asymptotes, Fabiana, where did that come from? Absolutely. As she said, since we already determined the domain to be all real numbers except for -3, that -3 tells us what? That's exactly where the domain was equal to 0, and that's what we're looking for the vertical asymptotes. So if you've already determined your domain, you've already found your vertical asymptotes. In this case, x equals -3. And for our horizontal asymptotes, what are we looking at again?
The degree.
The degrees. So what do we have here in relation to n and m? N our numerator, m our denominator.
I go first.
Well, what's the degree of the numerator? You see an x there? So what degree is that?
Correct.
Mm-hmm. So we have n is less than, greater than, equal to? N is numerator.
Right, it's equal to 0. No. Oh, less than that. Okay.
Right, my numerator is definitely less than the degree of my denominator, which in case gives us what for our horizontal folks? That's the one case that we had yesterday or Friday, right? Where we had that horizontal asymptote of y equals 0. So if we go ahead and plot this, let's say we have y-intercept of 0, 1/3. Asymptotes at x equals -3. And the origin. Do I have enough to plot this? Sketch this graph. No. You don't know. I mean, over here, probably a safe bet to assume that we're going to have a graph going like this. But we don't know if we have anything to the left of this asymptote x equals -3. Is it above or is it below? So we can go ahead and use these test intervals. Again, that last step, or second to last step, it said plot a point between each x-intercept and y x-intercept and vertical asymptote. So our x-intercept was none. Vertical asymptote, -3. So I split up the entire number line from -infinity to +infinity using those numbers. In this case, just a -3. So here we have that -infinity to -3, -3 to infinity, and then just come up with any particular value you want within that interval. Let's say -4 and -2. If you wanted -20 and -17, whatever. So from here we get the values of f as -1 and 1. So we do have two more points now. -4, -1. And -2, +1. What's this going to look like? But again, you aren't sure with this piece here whether it's going to be down here or up here, so sometimes you do need to get those extra points. Here we want to sketch the graph of f of x equals 3 plus 2x over 1 plus x. Raphael? Is there anything to do to simplify? you factor the numerator? Can you factor the denominator? All right, and it is as simple as it is. So, Francine, what about the domain? And how'd you get that? I can't. Absolutely, the denominator can't equal 0. So she said 1 plus x cannot equal 0, giving all real numbers except for -1. Coco, what about my y-intercepts? Absolutely. By letting x equal 0, we're going to wind up with 3 over 1, or just 3. So when x equals 0, our f of 0 say equals 3. So now we have that 0, 3 as our y-intercept. So this one. What about our x-intercept? Is that the numerator? All right, and that gives us what? As Alyssa said, we set that numerator equal to 0. Right, that's the same thing as letting y or our function equal 0. Setting that numerator equal to 0. When we do that, we wind up with an x value of -3/2. So -3/2, 0. Moving on, as far as finding our vertical asymptote's always a tough one, right? Absolutely. Just because we've already determined our domain. We know when it's not equal to 0, the denominator, or when we're excluding that point, the exact same thing as finding your vertical asymptote. X equals -1. And then Galena. As far as finding our horizontal, if we have any, what are we comparing? The degrees, absolutely. And so what are the degrees we have here? The relationship between n and m? Absolutely. And this is what somebody asked earlier. So here we have, right, we have a first degree and a first degree. So what does it become? Y equals 2, absolutely, because we take, as Adriana said, we take a look at the leading coefficients, right? My 2 and my 1. Just y equals 2. All right. So let's see. So now we have a vertical asymptote of x equals -1. A horizontal at y equals 2. It's a pretty safe bet that we know what's going on here. But if we needed to plot some more, again, here we want to go ahead and split up our number line, right, between the vertical asymptotes and our x-intercept. Our x-intercept was, the x value was -3/2. Vertical asymptote of -1. So using those two numbers to split up our number line, there's that -3/2. Again, using the number line to split up, I want to find a point in between each of my x-intercepts and my vertical asymptote. Well, my x-intercept was -3/2, and my vertical asymptote -1. So again, choosing some test points. I'm sorry? Okay. Good thing I chose that one too. -5/4 would work. And then 1, reevaluate. And we did wind up with 3 extra points now. So here you can see that first one, we have a -2, 1. -5/4 is -2. And +1, 5/2. Yes.
Why isn't it in the last question? There's only 2 test intervals, but this one there's 3.
How many points do we have as far as vertical asymptotes and x-intercepts?
Oh.
We have what? We have 2 points, so these 2 points are going to split up the intervals, 3 intervals. Over here, we did not have an x-intercept. We only had 1 point, so the entire interval from -infinity to +infinity only chopped it 2 pieces. But here with the 2 points, it split it up into 3 intervals. So here again, using our nice jagged curves, and we come up with our equation, or graph of equation, rational function. Right? So if there was actually 2 x-intercepts and 2 vertical asymptotes, that's 4 numbers, so we're going to actually have 5 intervals.
Yeah.
So here we want to graph, sketch a graph of 3x over x squared plus x minus 2. Michael, anything to simplify here? In this case, we don't particularly need to, but if we want to go ahead and factor that denominator, I mean, you can plainly see there is nothing to cancel out, but factor out the denominator, we get what? Absolutely. As Michael said, there's definitely nothing here to factor out. So from there, what do we get domain-wise?
All real.
Absolutely. Since we set that denominator equal to 0, we know that we cannot have that -2 and 1. Abby, what about my y-intercepts?
You just set x equal to 0.
Okay, so I got a 0 here, a 0 here, and a 0 here. Here. Absolutely. 0 over a -2 is going to be 0. So we know that I have my x-intercept, my y-intercept at the origin. And Miriam, what about my x-intercept? Again, we set what equal to 0? Okay, so setting our numerator equal to 0, 3x equals 0. What does that give me? So my x and y intercept are just 1 point right there at the origin. And you go. What about my vertical asymptotes?
Your vertical asymptote.
Absolutely. Taken just straight from the domain. Well, if you didn't evaluate the domain, right, we need to set that denominator equal to 0. So x equals -2 and x equals 1. And last thing we have to do is for Stephanie, go ahead and come up with those horizontals. Why is that?
Because the top one is the 1, the bottom one is 2.
Absolutely. Since I'm in the case n less than m, absolutely we come up with the y equals 0 as that horizontal. So if we were to plot these, let's see, we have the 0, 0. And then we also have vertical asymptote at x equals -2. And x equals 1. And right there at the x-axis for my horizontal. Is that enough information to graph? No, not at all. So, once again, using my x-intercepts and my vertical asymptotes. Again, my x-intercept, well, we know that's at 0, right? Y-intercept, I have one at -2 and one at 1, so I have 3 points. I'm going to have how many intervals? 4 intervals. Using my -2, 1, and 0. So I have from -infinity to -2, -2 to 0, 0 to 1, 1 to infinity, absolutely. And then coming up with some points. Okay. All right. Works for me, especially those numbers I chose to. And when you calculate them, this is what we come up with. The values of -2.25, 1.5, -1.2, and 1.5 presumed height. So, -3, -2.25, puts us right about here. -1, 1.5, 0.5, -1.2, and 2 at 1.5. What's this look like? But how can we have it crossing the horizontal asymptote in the middle, that x cubed? Isn't that a horizontal asymptote? What is a horizontal asymptote? Is that something I can never cross?
Oh, if you have an even number expression.
No, you can never.
I never defined a horizontal asymptote as something you could never cross. The definition of a horizontal asymptote, as x approaches infinity or -infinity, f of x approaches a certain number. So as x gets larger or as x gets smaller, it's approaching a number. Sure enough, we can see on the left, as x gets smaller, it's approaching y equals 0. As x gets larger, it's approaching y equals 0. Over here, it's not approaching without bounds. It's not approaching infinity or -infinity. It's just at x equals 0. So it's perfectly fine for a graph to cross once, twice, even multiple times a horizontal asymptote. It's just, where is it heading? Is it heading to that particular point? That defines a horizontal asymptote. Not that it cannot cross. Yes.
Is that the same for a vertical asymptote?
No, just a horizontal. Okay. Over here we have f of x equals x squared minus 4 over x squared plus 4x plus 4. So here, I want to simplify it. And then absolutely cancel. Here we know that right, x can equal that -2. So what is my domain? I pretty much already said it here, right? All real numbers. So then we want to go ahead and determine, excuse me, our y-intercept. Where x equals 0. So again, here we have 0, 0, 0. We're just left with, well, -4 over 4. 0, negative 1. Right? I'm just letting x equal 0.
And do you plug that into the new one?
Well, actually, you're actually right. You should actually be plugging into this one. You're going to come up with that same answer. My y-intercept, excuse me, my x-intercept. We're looking at, so if we say look at that new one. Here we were looking at just what? X minus 2 over x plus 2. So what is my x-intercept? Sorry. Well, here I have a, exactly, we're letting, excuse me, we just want our numerator to equal 0. So as E5 says, we come up with that x-intercept of 2, 0. And then to find our vertical asymptote, again, I'm not looking at the original. In this case, it doesn't matter. These are the same numbers. But from our domain, we already know that it's just going to be x equals horizontal, since they have the same. We're just going to take the quotient of the leading coefficients. So here of 1 over 1, y equals 1. So let's say we have a y-intercept at 0, negative 1. X-intercept at 2, 0. And vertical asymptote at x equals negative 2. And y equals positive 1. We're going to have to test some more points, right? But over here we get and due to sake time, or it's not sake time, due to the sake of time, we also wind up with something up here once you plot those extra points, right? Yes? Moving on to that last one. Again, we're going to start off with simplifying. Perhaps we have an x minus 1 in there that needs to be canceled out. If there's an x minus 1 that needs to be canceled out, it's actually going to be a straight line. It's y minus 1 would cancel, and it's just a linear equation. So here we have so nothing cancels out. But we do have a factor, right? You can see that the domain, all real numbers except for positive 1, right, where the denominator is equal to 0. What do we have going on here with our powers? Absolutely, we're going to explain asymptote, because here my numerator has one more degree than my denominator. I have a second degree divided by a first degree. So how do I go about finding that slant asymptote? We divide. So what am I dividing? Okay, so if I use synthetic division, what am I using? 1. And 1 minus 1 minus 2. Drop down the 1. What is that, negative 2? And what's left over here? What is this? That is just x. My slant asymptote is y equals that quotient, or in the y equals x. It's my slant asymptote. Right? And for my y-intercept, when x equals 0, we're just left with 2. Again, we're just replacing all the x's with zeros. We're left with a negative 2 over 1, or positive 2. My x-intercept, where the numerator is equal to 0, gives us what? Well, it's going to be y that's equal to 0. So, all right, so first of all, so we can say it's going to be x equals 2 and x equals -1, right? Excuse me. So we wind up with 2, 0, I'm sorry, -1, 0. And for our vertical asymptotes, it just comes straight from our domain. Thank you. So x equals 1. And then if we plot all this wonderful stuff, we have a slant asymptote at y equals x. We have a vertical at x equals 1. And then our points, y-intercept is 0, 2. And 2, 0. -1, 0. And we come up with a graph like this. Again, this one we didn't really need to find those extra points, but sometimes it is helpful. Questions, folks? All right. Aina, Oreo.
Could you, go through how you find x-intercept on
How do you what?
x-intercept?
How do we find the x-intercept points? To find the x-intercept, right? We want to find where y is equal to 0, or we're dealing with functions, where the function f of x equals 0. When is a fraction equal to 0? When the numerator is equal to 0. So from my x-intercept, let's just set it at the top. Equal to 0.
So then you do x squared minus x minus 2 equals 0? Oh, okay, go for 0.